In section 10.3, we're going to talk about conditional statements. In the middle of the page, on page 607, the gray box says, the study of if-then statements and their truth values is a foundation of reasoning. You can describe some mathematical relationships using the variety of if-then statements. So here's your key concept. This can be confusing, so if you find it confusing, you got to just study more. Key concept. You have 3 vocab words. First vocab word. A conditional is an if-then statement. A conditional is an if-then statement. So the symbol shows P and then an arrow, then Q. You read that as if P, then Q, and that's what the diagram looks like. If P, then Q, or P implies Q. You always start with the if P part first, P implies Q. The hypothesis is the part P, or the if part. The conclusion is the part Q, or the then part. So if we look at the got it problem on page 607, it says that we have to first identify the hypothesis and conclusion. So the got it problem says, what are the hypothesis and conclusion of the conditional? If an angle measures 130 degrees, then the angle is obtuse. Well, the hypothesis is your P or if part. So the hypothesis would be that an angle measures 130 degrees, and then the conclusion would be that the angle is obtuse. So look at problem 1 on the top of page 608, the hypothesis and the conclusion. The hypothesis would be what? If a figure is a rectangle, then it has 4 sides. So the hypothesis would state the figure is a rectangle. And the conclusion would be it has 4 sides. In problem 2, we're actually going to write a conditional. So let's start with our first problem. This one is not in your book, but we're going to do it first. We want to write the following statement, vertical angles share a vertex, as a conditional, which means you're using an if-then statement. So vertical angles is what we're talking about in the hypothesis. Share a vertex would be the conclusion. So let's write it as a conditional. I took the vertical angles part, and the vertical angles part is your hypothesis. If 2 angles are vertical, then they share a vertex. And the blue is your conclusion. So let's look at the got it. How can you write dolphins are mammals as a conditional? Try to do that yourself, and then write it as your own conditional. And then pause the video, and then play it after you figure it out. It should look like this. The first statement is that animals will be dolphins. So if an animal is a dolphin, then it is a mammal. Let's look at number 4. Number 4 says, write a conditional statement for the Venn diagram. Well, if you look back at your key idea, in your diagram, the P is always the inner part of that circle. So the if part's going to be your wheat. The end part, or the conclusion, will be your grains. So you could say something like this. If something is wheat, or if a piece of food is wheat, then it is a grain. So if something is wheat, then it is a grain, would be your conditional. Above problem 3 on page 609, the gray box says another vocab word. The truth value of a conditional is either true or false. To show that a conditional is true, show that every time the hypothesis is true, the conclusion is also true. To show that a conditional is false, find only one counterexample for which the hypothesis is true, and the conclusion would be false. Now, I always find these fun because all you have to do is prove something false to make it false. So we're going to start with A. We're going to prove whether or not these are true or false. Part A, or problem A. If a woman is Hungarian, then she is European. Is that true or false? It'd be true. And why is it true? You have to explain. Because Hungary is a European nation. So Hungarians have to be European. It's like saying this. If a woman is in Illinois, then she is American. Well, if you live in Illinois, Illinois is part of America, so you'd have to be American. Part B, if a number is divisible by 3, then it is odd. True or false? It'd be false. Because give me a number that is divisible by 3 but is not odd. You could say this, 12 is divisible by 3, but it is not odd. So all you have to do is prove something wrong to make the statement false. Now this is where it gets difficult. On the top of page 610, there's another box. Vocab word. The negation of a statement P is the opposite of the statement. The symbol, and then you can see the symbol, and is read, not P. So if you see a squiggly and then a P, that means not P. The negation of the statement, the sky is blue, would be the sky is not blue. You can use negations to write statements related to a conditional. Every conditional has 3 related conditional statements. You're going to have to take about 10 minutes and look over this chart. This is confusing, but I'll start you off with the first few. Key concept. A conditional uses the given hypothesis and conclusion. Then it gives you an example. If the measure of an angle A is 15, then the angle A is acute. And we've already done it. If P, then Q. The converse means you switch the hypothesis and conclusion around. If angle A is acute, then the measure of angle A is 15. And then you flip it around. If Q, then P. The inverse is when you take your conditional and negate both of them. So basically, it's if not P, then not Q. So basically, you say take the same thing in the conditional. If the measure of angle A is not 15 degrees, then angle A is not acute. And then you can see how it's written. If not P, then not Q. Contrapositive is when you take the converse and negate those. So our converse said if the measure of angle, or if angle A is acute, then the measure of angle A is 15. We do the opposite. If the angle A is not acute, then the measure of angle A is not 15. And that would be if not Q, then not P. You're going to have to take some time and memorize those. So we're going to go back to the next step, which talks about your statement and whether or not it's a true value. This is called equivalent statements. Equivalent statements have the same truth value. So if you look at where it says in the center of the page, the white region, and it says truth values, let's go back to our conditional with what we were talking about. If the measure of angle A is 15, then angle A is acute. Well, that would be true, because if something is 15 degrees, then it's acute. The converse said, if the measure of angle A is acute, then it has to be 15 degrees. False. Why? Because if something is acute, it could be 20 or 25 degrees. The inverse, if the measure of angle 15 is not 15, then angle A is not acute. That's false, because something could be 20, but it still is acute. And the contrapositive says if angle A is not acute, then it can't be 15. That would be true, because if an angle is not acute, it can't be 15, because 15 is acute. So you'll notice that the conditional and its contrapositive are equivalent statements. They are both true or false. The converse and inverse of a statement are also equivalent statements, because they are both false. So we're going to look at the got it on the top of page 611. If a vegetable is a carrot, then it contains beta-carotene. We have to find the converse, the inverse, and the contrapositive of this conditional statement. So this is our conditional statement. So if we first look at the converse is just taking your conditional and switching it around. So we were going to say, if it contains beta-carotene, then it is a carrot. The inverse and contrapositive are taking the first two and just putting knots in them. So the inverse is taking your original one and putting a knot. If it is not a carrot, or if the vegetable is not a carrot, then it does not contain beta-carotene. In the contrapositive, you take the converse and do the opposite of that. So if it does not contain beta-carotene, then it is not a carrot. So these are your three statements that you would make: the converse, the inverse, and the contrapositive. The next step is determining whether or not these are true or false. So the first one, if a vegetable is a carrot, then it contains beta-carotene. That's true. Converse, if it contains beta-carotene, then it is a carrot. Well, no, because there are other vegetables that have beta-carotene, and they are not carrots, so that's false. Inverse, if it is not a carrot, then it does not contain beta-carotene. Once again, you have other vegetables that do contain beta-carotene, so that statement would be false. And the contrapositive, if it does not contain beta-carotene, then it is not a carrot. That's true, because if it does not contain beta-carotene, it can't be a carrot, because a carrot does have beta-carotene. So we have true, the two center statements are false, and the last one is true. So then now we have to give the truth values. The true statements are conditional and contrapositive, and the false statements are converse and inverse. So the last step is we have to give a counterexample of the converse and inverse. Well, if we look at it, we know that there are other vegetables that contain beta-carotene. So you could say spinach contains beta-carotene. So the vocab that you would have in this chapter would be conditional, hypothesis, conclusion, truth value, and negation.